Welcome back to Fear No Number, where every challenge helps us level up our math skills and unlock our brain power. Ready? Let's go! In this video, we will cover inverse operations, part 2 of the 4-part video series.
All right, welcome back to the channel. Today we are absolutely crushing it. No downtime, no stopping, just pure energy right from the start.
In this video, we will cover the second part of rearranging equation. We call it inverse operations.
Don't let the name inverse operations freak you out.
It's just a fancy way of saying, do the opposite operation. So, addition becomes subtraction, multiplication becomes division, and squaring becomes square root, and so on. Do you remember our friends called BODMAS from our number games? Depending on where our BODMAS friends are when they travel around the world, they are also called PEMDAS, BIDMAS, BEDMAS, BOMDAS, GEMDAS. Even they are forced to swap round under inverse operations. So, subtraction and addition come first before multiplication and division.
So, inverse operation is all about doing the opposite.
Yes, that's it. It's all about doing the opposite.
You see, to rearrange equations, we need both balance and inverse operation. Our BODMAS friends can also help us when we are rearranging equations. We also have this great toolbox and the toolbox team to help us understand inverse operations.
But first, let me show you our toolbox.
So, here is the toolbox for inverse operation.
And here it is, your whole toolkit, laid out nice and neat. It's super intuitive, right? The opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring a number, taking the square root. Each pair in this table perfectly undoes the other. This right here, this is the key.
In our maths journey, do you remember the two great partners between addition and subtraction? And division and multiplication. You see, addition and subtraction are opposite partners, they undo each other perfectly. Multiplication and division are partners, they cancel each other out.
Solving equations means calling on these powerful partnerships.
Okay, let's see how the toolbox works. Look at these 4 equations. Let's remove 3 from each of the equations, so B becomes the subject instead of A. Let's see the toolbox in action. In equation 1, A equals B plus 3. We know what A is, it's B plus 3. But what about our subject B? What does that equal to? This is where we need help from the toolbox. Toolbox, please remove 3 from B to reveal what B equals.
Hi, my name is Toolbox. This task is an easy one for me.
Yeah, okay. Toolbox. Let's get to work now.
I handle PR for Toolbox. She gets a bit dramatic about new equations. She's under the impression that without her, we'd still be living in caves. Okay, enough said, let's get this done. Since 3 is added to B, we must subtract 3 from both sides to remove 3 from B. The final result is A minus 3 equals B. The convention is to present the subject on the left-hand side. So it looks like this. B equals A minus 3.
In equation 2, A equals B minus 3. Again, we want to know what B equals to. Toolbox, please remove 3 from B to reveal what B equals.
Since 3 is subtracted from B, we must add 3 on both sides to remove 3 from B. The final result is A plus 3 equals B, presented as B equals A plus 3.
In equation 3, A equals B multiplied by 3. As before, we want to know what B equals to. Toolbox, please remove 3 from B to reveal what B equals.
Since B is multiplied by 3, we must divide B by 3 and do the same to the other side. The final result is A divided by 3 equals B, presented as B equals A divided by 3.
Did you see how we cancelled out number 3 attached to B? If you are not familiar with cancelling out in fractions, take a look at this.
For anyone unsure about canceling out, here are some simple examples. 2 times 10 divided by 2 equals 10, 6 times 5 divided by 5 equals 6, 12 times 4 divided by 4 equals 12. Do you see the pattern in each case? The same numbers that appears in the top and bottom are canceled out, leaving the other number as the answer. Watch our video, Fear No Numbers, for greater insight of what we call number games.
In equation 4, a equals b divided by 3. Again, we want to know what b equals to. Toolbox, please remove 3 from b to reveal what b equals.
Since b is divided by 3, we must multiply b by 3 and do the same to the other side. The final result is a multiplied by 3 equals b, presented as b equals a multiplied by 3.
Here is the summary of the results in the toolbox. Can you see the pattern? Take your time and look carefully. If this video helps you, don't forget to subscribe, like, share, click the notification bell. You can help us reach more children to help them escape the fear of numbers. Here are 2 more examples you should pay attention to.
Class, I really need your attention on this one. Consider the equation y equals 2x plus 5. Our goal is to make x the subject of the formula. Right now, 2 things are attached to x. It's being multiplied by 2. It has 5 added to it. So yes, we need to remove both the plus 5 and the times 2. But here's the exciting part. Which one do we remove first? Do we remove the 2 first or the 5 first? This is where we need our BODMAS friends. This is where the inverse BODMAS rule comes in. Normally with BODMAS, we handle brackets first, then order second, third is division, fourth is multiplication, fifth is addition, and sixth is subtraction. So multiplication comes before addition, but when we're solving equations, we work backwards. We undo operations in the reverse order. So instead of following BODMAS forward, we reverse it. That means we undo addition and subtraction first. Then we undo multiplication and division next. So in this case, we remove the plus 5 first, not the 2. Therefore, step 1, remove the plus 5. Subtract 5 from both sides. So we have y minus 5 equals 2x. Step 2, remove the 2. Now divide both sides by 2. Now we have y minus 5 divided by 2 equals x, or x equals y minus 5 divided by 2. Great. X is now the subject, so the key idea is, when solving equations, we undo operations in the reverse order they were applied, and that's why we deal with the plus 5 before times 2. Algebra isn't random. It's beautifully logical once you see the pattern. Now consider the equation, y equals x divided by 2 and subtracted by 5. You may say, wait, this looks different, but it's actually the same logic. At first glance, it looks different from the previous one, but structurally, it's very similar. Our goal is still the same: make x the subject, get x completely on its own. Right now, 2 things are attached to x. It's being divided by 2. Then 5 is being subtracted. So again, we need to remove 2 numbers. The subtract 5 divide by 2. But here's the same question. Which one do we remove first? 2 or 5? This is where our good friends BODMAS come back, but remember, we're solving, so we use the inverse rule. Normally, BODMAS says division comes before subtraction, but we're not applying operations, we're undoing them. And when we undo operations, we reverse the order. So instead of undoing division first, we undo subtraction first. So, step 1, remove the minus 5, so we add 5 to both sides. We now have y plus 5 equals x divided by 2. Step 2, remove the 2 dividing x. We do this by multiply both sides by 2. We now have y plus 5 multiplied by 2 equals x, or neatly written, x equals y plus 5 multiplied by 2. It doesn't matter whether it's multiply then add or divide then subtract. The rule is always the same. When solving equations, undo operations in the reverse order they were applied. Algebra isn't about guessing. It's about reversing the journey step by step. And once you see that pattern, that's when algebra clicks. Now, it's your turn to have a go with these short exercises. The answers are at the end of this video.
Make sure you write down all the questions and give all or most of them a go before viewing the answers. Also, don't forget to subscribe, like, and share the video.
Pay close attention to what I say. In part 1 of our inverse operations questions, the starting point for question 1 is y equals x plus 3. For question 2, it's y equals x minus 3. In question 3, it's y equals x multiplied by 3. And in question 4, we have y equals x divided by 3. In each question, x is our subject. Get rid of 3 in each question to leave x on its own on one side of the equal sign. In part 2 of our inverse operations questions, the starting point for question 1 is y equals 2x plus 3. For question 2, it's y equals x divided by 2, then subtract by 3. Since x is our subject again, use inverse BODMAS to rearrange the two equations, leaving x on its own on one side of the equal sign. Now, let's try something a little more challenging. If you are not familiar with square and square roots, please skip this exercise. Our Number Games video series covers this topic. If that's you, fast forward to the answers for the last exercise. But if you are familiar with square and square root, give this a go. In part 3 of our inverse operations questions, the starting point for question 1 is y equals x squared multiplied by 3. For question 2, it's y equals square root of x divided by 3. Since x is our subject again, use inverse BODMAS to rearrange the two equations, leaving x on its own on one side of the equal sign.
Are you ready to go through the answers to the exercises? Ready? Let's go!
In question 1, y equals x plus 3. To leave x on its own on one side of the equation, we need to remove plus 3 from the side of x. We can do that by subtracting 3 from both sides of the equation, leaving us with y minus 3 equals x, or x equals y minus 3. Continuing with part 1, question 2, y equals x minus 3. To leave x on its own on one side of the equation, we need to remove minus 3 from the side of x. We can do that by adding 3 from both sides of the equation, leaving us with y plus 3 equals x, or x equals y plus 3. Moving on to part 1, question 3, y equals x multiplied by 3. To leave x on its own on one side of the equation, we need to remove the multiplier 3 from the side of x. We can do this by dividing both sides of the equation by 3, leaving us with y divided by 3 equals x, or x equals y divided by 3. Finally, in part 1, question 4, y equals x divided by 3. To leave x on its own on one side of the equation, we need to remove the 3 that's dividing x. We can do this by multiplying both sides of the equation by 3, leaving us with y multiplied by 3 equals x, or x equals y multiplied by 3. In part 2, question 1, y equals 2x plus 3. To leave x on its own on one side of the equation, we need to remove the 3 and 2 from the side of x. We start by first removing the plus 3 using inverse BODMAS rules, leaving us with y minus 3 equals 2x. To finish off, we need to remove the 2 that x is multiplied by. To do this, we divide both sides of the equation by 2, leaving us with y minus 3, then divide by 2 equals x, or x equals y minus 3, then divide by 2. In part 2, question 2, y equals x divided by 2 minus 3. To leave x on its own on one side of the equation, we need to remove the 3 and 2 from the side of x. We start by first removing the minus 3 using inverse BODMAS rules, leaving us with y plus 3 equals x divided by 2. To finish off, we need to remove the 2 that's dividing x. To do this, we multiply both sides of the equation by 2, leaving us with y plus 3 then multiplied by 2 equals x, or x equals y plus 3 then multiplied by 2. In Part 3, Question 1, y equals x squared multiplied by 3. To leave x on its own on one side of the equation, we need to remove the 3 and the power 2, also known as exponent 2, from the side of x. We start by first removing the multiplier 3 using inverse BODMAS rules, leaving us with y divided by 3 equals x squared. To finish off, we need to remove the power 2 that x is raised by. To do this, we apply the square root to both sides of the equation, since square root is the inverse operation of squaring. This leaves us with square root of y divided by 3 equals x, or x equals square root of y divided by 3. In Part 3, Question 2, y equals square root of x, then divide by 3. To leave x on its own on one side of the equation, we need to remove the 3 and the square root of x. We start by first removing the 3 that's dividing the square root of x, using inverse BODMAS rules, leaving us with y multiplied by 3 equals square root of x. To finish off, we need to remove the square root of x. To do this, we square both sides of the equation, since squaring is the inverse operation of square root, leaving us with y multiplied by 3, then squared equals x, or x equals y multiplied by 3, then squared. Did you know that letters in algebra can actually be negative? In the next video, we're taking things to the next level. We're no longer just calling them letters. We're going to use their real mathematical name, variables. We'll explore what happens when variables become negative, how algebraic fractions work, and how powers, also called exponents, change the value of a variable. Get ready, because algebra is about to make a lot more sense. Because our world is ever-changing and complex, we have many equations in many forms to help us solve the many problems we face in the world. So you must practice many types of equations to master algebra.